Hello, my name is Professor Johnson, and today we will be talking about the uniform distribution. With the uniform distribution, let's recap a few important things. So x is distributed uniformly from A to B, and you can think of A and B as your starting to the end point. Visually, it would look like this. So A and B could be started anywhere on x. And then for your outputs, you're actually going to have a certain height, and we'll call that f of x. Now, if you were looking for the mu, the mean of our example, so this is mu, Greek mu, the mean would come from A plus B, and you divide it in half, which would kind of bring you right to the center, maybe approximately there. I know this isn't to scale. And sigma, okay, another Greek letter, sigma comes from this crazy formula, b minus a all squared divided by 12, and you take the square root of it. Okay, now let's talk about that f of x. So you see how this is kind of like your height. You see how you have a rectangle there? This height is our f of x. Now f of x is really what's called the probability density function, our PDF. F of x comes from 1 over b minus a. Okay, we're going to use this value. Now a is always between, or x is always between a to b, okay? Our starting and our ending point. Okay, now if you're thinking of a CDF, CDF is going to be the area under the curve. Okay, now our curve in this example is our f of x. Okay, our function, our PDF. So we're going to find certain areas underneath this rectangle right here. Okay. Now, if you think of this whole thing, this whole rectangle has an area of 1 right now. All right, so let's work on an example to put some of these formulas to use. Okay, so imagine that the time it takes for a student to complete a quiz is uniformly distributed between 5 and 15 minutes. We want to draw the distribution and find the probability a random student takes at most 8 minutes to complete the quiz. Okay, so I highlighted a couple important things. First, let's draw the distribution though. So I'm going to start with my axes. Okay, x goes here. 5 and 15 minutes. So I'm just going to mark 2 spots. There's my 5, there's my 15. Now, we've created a rectangle and a uniform distribution. We have equally likely events to occur anywhere in between. So a student finishing the quiz at 8 minutes is equally likely to occur that a random student finishes at 11.2 minutes, right? Anywhere in between, okay? It could take 5 minutes and 32 seconds for one student is the same chance as occurring as a student finishing at 14 minutes and 12 seconds. Okay, but what we're interested in is that height, that f of x. Okay, we need the height of this rectangle. So f of x is 1 over b minus a. So we have 1 over 15 minus 5. Gives you 1 over 10. Okay. Now be careful if you type that in your calculator to put parentheses around the denominator, otherwise you'll make a mistake. So our height is 1/10. Okay. Now we've drawn our distribution, but now we want to find our probability. Now I'm going to start with the probability notation. Takes at most 8 minutes. So the probability that x, and then we need to figure out the inequality that goes before 8. Now, if 8 is about there, so mark this, mark our 8, and at most 8 minutes. At most 8 tells you that you're not going beyond 8. It's most 8. So we want this shading, right? We want this shading right here. Okay. So for an inequality, that would be probability that x is less than 8. And you could be less than or equal to. With continuous, it doesn't matter if you put either inequality symbol. Now probability is coming from the area. And our area here would be base times height. Okay, so I'll just write that in. Base times height. Because that's an area of a rectangle. Now the base, from 5 to 8, you see, that is 3 units. So then 3 is our base, our width, right? And our height, or the length, is a tenth. So 3 over 10 would be our solution, or 0.3. Okay, now we know that this is a valid solution because probabilities are always between 0 and 1. All right, now let's continue with the same example, but theoretically, on average, how long will it take for a random student to complete the quiz? Okay, so in theory, when will they complete the quiz? Now, since everyone has equally likely chance to complete it, what we need to find is the mu, the mean, and we do a plus b over 2. And 5 and 15 were our starting points from right here, 5 and 15. And you divide that in half to get right to the center, the midpoint. 5 and 15 add to 20, and then half of 20 is 10. So we have 10 minutes as our solution. You always want to put units with your answer if you know the units. Okay, so that's our average, our mean. Now you could also practice finding standard deviation if you'd like by using the sigma formula on our first slide from here. Okay, but let's take you to the big example. So example 3, it says given that a random student has been working on the quiz 10 minutes, what is the probability of the student finishing the quiz in less than 12 minutes? Okay, what I'm going to do first is draw the original distribution. So from 5 to 15, and we know that that was a height of 1/10. Okay, now this type of example is called a conditional probability example. Okay, conditional probability. And that's because we have the special word right here, given. We are given some information. Now we've been given that they've been working on the quiz 10 minutes. So I'm gonna mark right here will be 10. Now that they've been working on the quiz 10 minutes, we don't care that they've been working 5 minutes, 6 minutes, 7 minutes, 8 minutes. We don't care about anything before that. They are working for 10 minutes, right? We're given that information. So what happens now is 10 is our new starting point. 10 is your new beginning. And this is actually going to create a new height for us. Okay? And it's actually going to increase larger that way. And if we go to the left-hand side, we want to find that height. Now, we still do 1 over b minus a, but now it's 1 over 15 minus 10. So that becomes 1/5. And 1/5 is a little bit greater than a tenth, so we know that this visually makes sense to us. Okay, so with conditional probabilities, anytime that there's a given statement, you create a new height only when you're given extra information. Okay, now we want to find the probability, so it's asking the probability of the student finishing the quiz in less than 12 minutes. So the probability that X is less than 12, but we were given that they've been working on the quiz 10 minutes already. So I'm going to say right here, that vertical bar that I've inputted there relates to conditional probability is our given statement. So the probability that X is less than 12, given that they've been working on it for 10 minutes already. So when are they going to finish? Now probability, we know we're going to be looking for the area under the curve. Now less than 12. So if I mark 12 here, really I'm looking for that sliver right there. That sliver right there. So the base, we want base times height. The base is 2, right? 10 to 12, that's a base, a width of 2. And then the height is 1/5. So you have 2/5 as your probability in this example. Okay, thank you for watching.